Ladies and gentlemen, I'll make a presentation which is from conditions in a temperate climate, and that is in a situation where there's an abundance of wind power. Some of it is already realistic to deal with, but others is part of a future situation. I've already been presented, and we can move to the next. We know that consumption of power is steady, but wind power fluctuates. Solar energy also fluctuates, and that causes special problems. We have, in any system, we have electrical system, we have some consumption. Next. Well, there's missing one part here. We have some production coming in. Okay, we have production that can be regulated, and we have here production that cannot be regulated, and then there's be some export. What is this export going to be? Export can be to different ways. It can be export to other countries, it can be to storage, but I'm also here to present today, and this is in the title of the presentation. It can also be used for heat needs, the need of heats. This is for this presentation is a very important graph. What we have here is these are measurements made over the first 8 weeks of 2007. And what we see here is that this is a normal week here with 5 days of work and the weekend when consumption is low. And we have so these consecutive 8 weeks. And we have down here the wind production, and you see that already now, periodically wind reaches so that it's covering 100% of the demand for electricity. This is already the situation now. And this is with 3,200 megawatt of wind power. And we are additional 3,000 megawatts, which is already planned, and some of it will be there already in 3 years' time. We see that for many periods, the wind is so much that it is covering much more than the 100%. And what to do about that? Already now, the utility or the system operator has the permission to stop the wind turbines when it makes more than 100%. And we have a special problem in Denmark due to the high share of combined heat and power, that for the need for heat, there is a supply of power into the system, and the wind turbines are also at the maximum. And just at the weekend here before this conference here, there were 3 days of quite strong wind. Many wind turbines were turned off. That is the situation now. Wind turbines have stopped because this is developing faster than the system is adapted to it. It's not a matter of grid capacity system, it is also a matter of economical aspects. It's a problem to sell it. Denmark has connections to other countries, and the blue ones here are new ones coming, but the red ones are existing connections. Denmark has the most connections of any country in Europe to other countries in comparison to the size of the country. In total, it has as much to the neighboring countries as a country like France, which is a 10 times bigger country. So the solution is not only to make bigger grids and sell it to other countries when there's too much. There must be found other solutions, because grids are very expensive to make also. This is an illustration of an actual situation. We see here a consumption, and this is a certain day of this September 2009, 3:30 in the afternoon, that the consumption was 3,200 megawatt. The wind power produced 2,100, it means 2/3 coming from wind, and so much was from big and small power stations. Next one. To absorb this additional capacity, which is a growing problem, because export to other countries is in some way not very attractive. If in the northern countries, I mean Norway and Sweden, they have much water, they will pay very, very little for the power from wind, maybe 1 cent or less, or maybe even a negative price. With as much wind, and then we could say we could sell it to Germany, it's a big country, but they also at the same periods have plenty of wind, and will also pay very little for it, maybe even a negative price. So there has to be found a new solution. And the possibilities here, that is electrolysis. fuel cells, that's boilers for hot water and heat, and compressors for heat and turbines, and pump pump storage, and that's from AC/DC and back to AC through batteries. These are solutions that are available, and I have heard here this conference and people speak about the solutions. We just need storage. But the cost of storage, and also the efficiency of storage is extremely different. If we take, for instance, our fuel cell electrolyzers, there's a cost per kilowatt in euros is about 10,000. For electric boilers, it's 200. For electric heat pumps, it's 2,000. I didn't bring a price for these here. If you take batteries AC to DC to AC again, it could be about 4,000, and flywheel is around 3,000. These prices can be very different from part to part in the world, and you can certainly find some which are more expensive, some which are more cheap. Then we also take just to have an overview of what it costs to produce conventional power. Our prices used in Denmark and the Nordic countries. Atomic power is 5,000. Wind power is around 1,200. Natural gas engines is 700 as combined heat and power. Biogas combined heat and power is 2,500, and photovoltaic around 3,000. I will focus, just go back please. I will focus on this one here, because at this stage of development, it's relatively few hours of the year. It's relatively few hours of the year that we have this excessive capacity. And to make an investment just to absorb it, you must have to make an investment to absorb big quantities. You must also have many operational hours. And we don't have many hours to operate on surplus at this moment here, but this we can do. Therefore, we have to choose the low-cost solutions. We also have to look at the efficiencies. Please next one. The efficiencies is so that for electrolyzers and fuel cells, we can have losses. I'll show a graph a little later what I mean, of 75%. For the electric boilers, we have a loss of nearly nothing, because there's no conversion loss. And for the heat pumps, even there is plus 300, 200, 300, 400%. So we get more than we feed into it. And if we talk for air compression, it would be around this here. And there's a loss of batteries of around 35%. Flywheel I will not mention. These are losses in conventional power plants. This is 60 and 65 and 50. So out of this here, what I will point at, and this is this stage of development, point at this solution here and this solution here. Well, but I did not mention, just one back again, sorry. We also, when we discuss these issues here, and when we want to have production of power coming from combined solutions, and wind and solar is included, then we need supplying systems which match well and that can respond quickly. And which solutions here for the generation can respond quickly? The conventional coal needs around a day or so. Often it needs a day to adapt. This needs sometimes much more than a day. Wind power, I didn't bring in for this here, but natural gas engine CHP needs 1 minute or so. In 1 minute it can be at full power and compensate for the wind power fluctuations. So this is why the use of photovoltaic and wind power in the system, they need technologies that can adapt quickly, and this means that the conventional coal